will talk predominantly about the work we've been doing in the mobile health space today, but as Nathan alluded to, our background at SAGE really comes from the perspective of data and resource sharing within the genomic research world, and it's really influenced the way we've thought about mobile health and where we see our unique contribution can be. So I'd like to start there. So SAGE is nearly a decade old, which is kind of amazing, and was born of the premise that many people are doing really amazing, cutting-edge work. At that point, it was in the genomic space. Same thing here for mobile health, but they're still largely doing it in isolated instances. And you can understand how this started, right? As science was developed, we all work separately in different academic research institutions with different expertise and different funding sources. And so when you have a hypothesis that you want to answer, you go out, you think about how you're going to go about designing your experiment, you enroll your participants, you collect your data, be it mobile data or genomic data, and then you figure out how to analyze it. But actually, this is largely very inefficient, and it often leaves us with not enough data or not the right methods to really address the questions. And so we've been thinking about ways that we can learn from each other or share resources across each of these three instances. And really, we argue that right now is really a time when we can start to do that because the world has changed and we are much more networked. We have cloud infrastructure. We have the ability to very seamlessly share our data, our methods, and our ideas through common technical platforms in a way that just wasn't possible before. And so our interest has been in building infrastructure and services that allow people to do that, and then where it makes sense, work with them to identify the best approaches for them to use their collective research community to answer the questions that they themselves have. And so the first thing we had to do was to build an infrastructure, a software platform that could be used to enable each of these individual communities. That's called Synapse. At the time we built it, it was a prototype for how such work could be done. So it's essentially a cloud-based platform that allows people to share data with governance, a governance framework around it so that you can actually share human data. But on top of that, you can share your methods. You have the opportunity for social interaction and commenting on top of that, and you can really start to create the infrastructure for a community. Actually, there are a wide variety of other software solutions out there now that people can choose from, and increasingly they're being developed in ways where they can interoperate with each other. So it doesn't necessarily matter the first solution you choose, you should be able to interact with other research communities around the world. So that's all well and good, but what do people actually use such a framework to do? And so I want to take you through a quick example of a project that we got involved with in colorectal cancer subtyping, where we were able to help a community learn from each other. And so this example starts with the observation that in 2013, multiple groups around the world started publishing essentially the same analyses that they were each doing independently. So they were each interested in doing genomic subtyping of colorectal cancer. And so the first groups started to do this. They generate their data, build their methods, perform their analyses, identify their subtypes, and publish these. And when we got to group 4, it was becoming increasingly difficult for these groups to publish because the community could not understand how the various subtypes that were being called across these groups interrelated with each other. They couldn't come to consensus. And so we, as a neutral party, could come together with these groups and say, let's do a benchmarking evaluation to understand what it is that each of you have identified and how they may interrelate. And so we go from this approach to science, where groups A through F are using data sets 1 through 6 and methods 1 through 6 and identifying different subtypes, to a method like this, which is multiplicative. So each group is using their personal method on all of the data sets, and we can start to look across this matrix of data sets by methods to understand where the commonalities are in the subtype analyses that are coming out. And so this analysis brought us to this map of subtypes, genomic-based subtypes of colorectal cancer, which showed 4 major subtypes that were universally seen across all of the methods when performed in the data. And actually, this has allowed the community not only to have a better understanding of what these outcomes are, but much more rapidly move forward to use these subtypes within the context of a clinical trial, because they've established this in a way that has universal consensus. So that was a brief example of what the kind of work that we do. We're doing this actually in dozens of different projects. We work with Nathan on an Alzheimer's disease project, AMP-AD, which is we're doing similar sort of things in that space. But what we often found as we go through these genomic analyses is that you can have millions of molecular traits you're looking at, but often you're still analyzing them relative to a single phenotype of case control status. And that is simply not an appropriate manifestation of what disease looks like out there in the real world. And so not only do we see that disease manifestations vary across individuals, but, and I think this is no surprise to anyone in this room, right, but the way a disease affects an individual also fluctuates greatly over time, and that is simply not captured in most of the phenotyping efforts that have been done to date, and certainly not integrated into genomic analyses. And so being an organization that's interested in supporting the greater research community through infrastructure to help test new approaches, we moved into the world of real-world phenotyping through mobile health. And we did so by creating a set of infrastructures to help with enrollment, collection, and analysis of mobile health data, really specifically data coming in through a smartphone. We had the great opportunity as we were building out, in particular, the e-consent process for enrollment and the bridge study manager for data collection to partner with Apple in the development of Research Kit. And so both e-consent and the bridge study manager were embedded into a series of studies that Apple promoted in 2015. And so this gave us the opportunity to test our systems at large scale really rapidly. And so we've had more than 100,000 individuals go through both of these systems to help us understand where they work and where they don't, and how they can be honed to help the larger community. And so the first of these is the electronic consent process. And so we were busily developing a consent process that allows remote enrollment of participants into research studies on their own, self-administered through their phone. And we were building this within the context of actually 2 research studies that we were piloting, Empower, which I'll talk about in a little bit more detail, which is a Parkinson study, and then a second study that was looking at the effect of chemotherapy on cognition in breast cancer patients. And so we built a consent process specifically really for those 2 populations, where individuals are presented with the information about their research study, and then they are asked, in fact, to complete a quiz demonstrating that they have comprehension of what is being asked of them and what the purpose of the research study is. Then they go through a process of electronically signing the informed consent, email verification, and then are thus enrolled into this study. And so I think, very importantly, we made the very conscious effort that everybody had to complete this quiz and get all of the questions 100% right. And that was largely because we were looking at populations that specifically are known to have some cognitive decline, and we wanted to make sure that these individuals really knew what they were getting into. And so we required 100% accuracy. Even so, we've gone back and done a qualitative analysis through the comments that come in through the app to evaluate comprehension. And what we see that some people very much understand what's going on. Other people still do not, despite having gone through this process. So how do I know that the activities that are occurring in this app are actually helping me with my disease, right? Despite going through a consent process that very clearly demonstrates that this is a research study for us to understand the feasibility of running such an application. And so, well, this is perhaps disheartening. It actually is very much parallel to what one sees with traditional consent processes. And so we are in the process of doing some formalized analyses of this electronic consent process relative to traditional consent process, but we are also in the process of adapting it. So, as I said, the electronic consent process has now been deployed across dozens of apps. It's open source code that actually can be downloaded and integrated into any application through Apple's ResearchKit framework, and therefore has been reused many times, and in fact is probably not designed appropriately for other populations, healthier populations, the ones we were looking at. And so there's been a fair amount of feedback, and user interviews have demonstrated to us how we can make this process both easier for people to comprehend, easier for people to complete, and appropriate given the population that you're looking at. And so just not to belabor the point, just want to say that electronic consent is something that looks to be viable and useful for doing remote studies, but also needs to be adaptive to the study that you might, in fact, be looking to do. Okay, so as I said, these processes for data, or for enrollment and data collection were looked at across dozens of studies. And here's an example for 4 studies that were in the first range, just giving you an indication of the distribution of people who were able to download the app and, in fact, enroll in the study. And so what you can see is that you get a wide distribution across, in this case, the United States, because this was a US-specific study. What I'm not showing you here is that tens of thousands of people enrolled in these studies over the course of weeks. And so it's a really rapid way to be able to distribute a research study to a much wider group of people than you would normally be able to get access to. And this is particularly important if what you're wanting to study really is the diversity in a population for a given disease or health condition. So if we then focus in a little bit more closely on one of the apps, again, this is the Empower Parkinson's app, we can take a look at, in fact, who enrolled. So we ended up with about 10,000 controls and 2,300 Parkinson's patients that enrolled within the first 6 months of the study and provided us with some information. The study was designed as such. I mean, really, it was a feasibility study to see whether people would download the app at all, whether they would enroll in the study, and then, given that they did that, whether we could actually collect useful information through the phone. And so we collected 3 kinds of information through the phone. We administered a set of clinical surveys, exactly the kind of survey that such Parkinson's patients would actually get in the clinic when they went in for their exam. These are a survey about disease severity and a survey about quality of life. We then asked them to perform a series of active tests, each of which was designed to represent a test that the patient might do in the clinic, but actually use the sensors in the phone to capture a quantitative, objective evaluation of how well they're performing the test. And we actually think, this does two things. It allows you to perform such tests remotely, but it actually probably captures your activity more objectively than perhaps would even happen in the clinic. So an example is a very simple tapping test. Take your phone, place it as such, take 2 fingers, and for 20 seconds, tap back and forth as rapidly as you can. Now, this is actually a test that is done all the time in the clinic. It's actually a test used in standard of care for Parkinson's disease. And what a clinician will measure is how many times you've tapped. So we can certainly capture that through the phone, but we can capture a whole host of other features regarding how well people are tapping as well. Things like how variable are their taps? What's the pause between when we tell them to start and they actually start? All sorts of second-order features that, in fact, look to be more informative than the first-order features that are being captured in the clinic. Same for a very traditional gait and balance test. Take the phone, put it in your pocket, walk for 20 feet, turn around, stand still. So the third thing we started to capture was passive data feeds, because we can think about using the phone to ask people to do these activities, but that requires them to, in fact, open the app, perform the activity, and to think to do that, to actually interact with the study. Being able to capture data a little bit more passively and continuously, if it can give us the same information as this, and in fact this, would be very powerful indeed. And so the study was designed to help us start to understand that within the context of Parkinson's disease. So I just wanted to give you a flavor for what the data might look like. So here are accelerometry readings coming off of the phone for an individual doing the walking portion of the gait and balance test. So we thought carefully about exactly how we might want to deploy this test, because we could have simply used step counts coming either off the phone or a wearable to evaluate how far somebody was moving in this test, or GPS. But in fact, what we find is twofold. One is the number of steps somebody takes, a Parkinson's patient takes on a good day versus a bad day, may not actually be a very good characterizer of how well they're feeling. And the other thing is actually that the algorithms used to calculate steps from accelerometry are honed in a healthy population and actually are not very accurate at all in an individual with Parkinson's. And so we went back to the accelerometry data itself so that we could try to get a look at it to understand what portions of it might, in fact, be telling us something about disease. And so the first thing I will say about this is the following, right? This is real-world data, and it's very messy, because these tests have been administered in a completely uncontrolled environment. So what I can show you is 2 examples of that. This, again, is somebody who performed this test the same as the first, but it looks very different, because this person took the phone, put it in their pocket, started walking, wondered if they were done yet, picked the phone back out of their pocket, looked at it, put the phone back in their pocket, and kept walking. Right? So those sorts of things you have to look for in your data, because of course they're anomalies. And this one is even better. This person took the phone, saw that they were supposed to walk, put the phone on the table, and did the walk, right? And so right there are, things as easy or obvious as this, we can certainly build semi-automated mechanisms to QC the data and pull things such as this out. But as we look at the rest of the data, what we find is the thing that we can best predict in this data is you. So everybody has a very distinct walk, maybe not that distinct. Everybody has a very distinct walk. How you walk down this stage and back is very unique to you. And so we can, again, as you heard Mike talking about, take that information and look at it as how you may be performing relative to yourself much more than we can relative to others, which is to say, it's not that easy to find case control differences with the gait and balance. But what I can see is differences in a given individual over time in how they're walking. One thing that we've been doing since that time, and this is the data for the tapping test, is actually embedding the app in a series of clinical studies to understand a little bit more clearly how the information that we're pulling out of the mobile health app compares to what a clinician might diagnose in terms of disease severity or other more nuanced measures. And so this is simply showing that, in fact, we do see a distinct relationship between these two things. And that allows us to have some confidence in starting to look at the data coming out of the mobile application for a given individual. And so, as I say, we have a hard time really distinguishing, or really accurately distinguishing, cases from controls. So as of yet, with our current algorithms, I don't have a lot of confidence in this as a diagnostic. But what we do see is much greater variation in daily performance in cases versus controls. So the variation, the variance in the performance is very case specific. And what might that be? Well, for any of you that know anything about Parkinson's disease, you will know that, in fact, the standard treatment of care for this is L-DOPA, and this is something that is administered daily or even as many as 4 times a day. And it has a really short half-life on the order of hours. And so we can actually take a given individual. So what I'm showing you here is tapping, number of taps, very simple, for a given individual multiple times across the course, order of a couple of months, where red shows how well they could tap before they took their medication, and blue shows how well they could tap after they took their medication. And so this is a very big source of variation. It doesn't actually account for the variation I showed you earlier. That was actually only people off of medication. So there's variation in performance from a day-to-day basis in individuals, and on top of that, you can see a very clear treatment effect. And so you can think about how something like this might help you in a clinical setting to maximize or hone in treatment, particularly for a treatment such as this, which has a very active management process. So the L-DOPA schedule is changed rapidly and frequently for a Parkinson's patient over the course of their disease. And remember that we measured not just taps, but a whole series of activity tasks. And so we can actually look across all of the individuals in the study to understand how well their performance on these individual activity tests is showing us their treatment effect. And so what we find here, and this is a little bit busy, but you can see that for about 25% of the people, their performance on tapping tests is very highly affected by their treatment. But that for a whole series of other people, including many who don't show a tapping effect, in fact, we see a very clear treatment effect in one of the other activity tests that's measuring a different symptom or component of their disease. And so this is to say that not only is the disease manifesting very differently across people, but how they're responding to a standard treatment is very personalized across symptom domains. We can take this information and start to look for subtypes, subclasses of Parkinson's patients based on their response to treatment, to start to understand how these things might interact with each other across symptoms. The last bit from Empower I want to mention is that there are some individuals who may or may not have a treatment effect, but for whom we see variation in their response that seems to be independent of or in addition to any treatment effect they may have. And we asked all of the Parkinson's patients to tell us with free text what is it that made you feel better or worse today? To get an understanding from them directly as to what it is that they think is influencing the day-to-day fluctuations in the severity of their disease and how they're able to live with it. And so you can see some things that maybe you yourself would have suggested. Exercise, sleep, work, walking tend to people associate with days where they feel better. Depression, mood, sleep, pain, they associate with feeling worse. And so we can go back and start to look at how some of these factors, these lifestyle choices that individuals are making, are affecting their disease on a daily basis. Just to say that we're starting to expand this work to look at some other diseases, and we're very interested in the intersection of some of these quantitative measures with qualitative measures as well. And so a study that we're in the process of developing is looking at a series of diseases that cause transfusion-dependent anemia. So these are individuals who need transfusions on as frequently as a monthly basis. And so right now, they're treated simply to their hematocrit. So how many red blood cells do you have is the only factor that's taken into account when deciding when and how to treat. Whereas in fact, we know that even for a given hematocrit, there's a wide range in how people are actually feeling and how it is they're actually able to live their life relative to this disease. And so intersecting these more standard laboratory measures with some objective measures of quality of life may in fact greatly expand how we understand this disease and how we might manage it, either on a personal level or through the clinic. Now, I think mobile health, it's an exciting new area, but it's certainly not without its own complexities. And so what I'm showing you here is retention, right? So this is how many times, how many individuals came back and used the Empower app more than 5 times, ranging from 6 times up to 150 times, right? And so you see that there's a really rapid drop-off. Actually, this is a drop-off that looks a lot like any application that you might have on your phone, but presumably doesn't look much like what we see in traditional clinical studies, where once somebody's enrolled, they're much more likely than this to stay with the study. And so again, we can go back to our participants to understand what they think might be motivators for them in using this study. And I highlighted some of them here. Individuals would like to see more for themselves, how they're doing over time relative to themselves or to their other constituents. They'd like to see it gamified. But I think that for us, what we heard time and time again, which is represented here, is that people really wanted to think about how they could use the information in the app itself to help them manage their care, whether that meant bringing a report to their clinician when they went every 6 months, or in fact looking at the data on a daily basis themselves and thinking about how they might modify their behavior to live with their disease. And I think, well, we started looking at such data collection within the context of research, it simply has to move into the direction of clinical care to be effective. The other way we can improve retention, of course, is by thinking a little bit more about how we can move from those active tasks, where you have to open the app to use them, into more passive data feeds that might look at your behaviors within your phone to try to get at the same information. And so we're very actively thinking through and testing some of these mechanisms for enrollment and retention and efficacious use of these approaches within the context of a new study that's due to launch this summer through the Precision Medicine Initiative. So this is meant to be the All of Us cohort is meant to be a 1 million person longitudinal study across the country, which is collecting blood samples, electronic health records, sequencing data, et cetera. And we have the opportunity to start to look at how we can embed mobile health approaches into a study such as this to augment and complement the data that's already there. And clearly what we see is we don't know for sure what the right way to do that is, and we're going to have to test a variety of approaches. So I'll end there just to say that I think we're learning from each other in mobile health, just as we have previously in genomic, and it's really still early days, but there's a lot of promise.
We have a few minutes for questions. If there are any, looks like we have some lining up.
We're going back to our seats, Nick.
Yeah, go ahead. Go ahead, Mark.
All right. Well, we were actually just heading back to our seats, but since you called me out, I'll ask you a question.
Sorry, I thought you were waving at me.
No, it's okay. It's okay. So we're actually doing some similar work in rheumatoid arthritis at Janssen, and I'll give you an anecdote and then try to think of a question while I'm telling you the anecdote. So Jeff Curtis, who's an investigator at UAB, was doing a similar study, and it goes along with your story of the patient or the subject putting the phone down. Rheumatoid arthritis, you want to measure sleep and movement, right? So they had one subject in a very small study. Turns out her movement went essentially to 0. Very strange, right? So they said, why? She's a writer. First time in a long while she felt good enough to sit at a typewriter and type. And that's what she was doing. So she was essentially flatlined, and it was fabulous. So I am curious about, so that's just the anecdote part. So I'm curious what you guys think of the little companies that are popping up to try and do the same thing, to commercialize aspect of personal health and data. Any thoughts on that and how that might complement or compete with the SAGE model?
Sure, I think that there's many approaches to this, and they all get at it a little differently, and I have no problem with that. I don't actually find them to be competitors. I think our interests are in exploring the space and understanding how and where such approaches can be deployed, and if somebody wants to then go through the process of taking one and commercializing it, fantastic, because I think the approaches a for-profit company take may also very well be designed to help patients as well. That's fine.
Great. Ravi, last question for now, and then other questions we'll hold till for the panel.
With all this data, are you able to disentangle correlation and causation? Like, for example, when they were saying what made them feel good or what made them feel bad, well, maybe those were days that they felt good enough to exercise, or they felt depressed because their symptoms were bad, you know.
Right, absolutely a valid point, and no, not as of yet, no.
Great. Well, thank you so much, Lara. Look forward to the panel later.